So one of the first things we want to do with our new radian measure is learn how to convert from degrees to radians. We have two different ways to represent an angle. So how do we make that conversion? And it basically comes down to, let's go ahead and take a look at a full rotation. So in a full rotation, right, in degree mode, we have 360 degrees. And then what we just found out in the last videos, in radian mode, we have 2 pi radians, or about 6.28 radians, radius lengths along the edge. Now what we're going to do, remember what I'm trying to do is build a conversion factor, right? So in no way am I claiming that these two are equal, because this is like 6.28 and this is 360. So the equality I'm writing is not a true inequality, right? I'm not inventing math and saying that 6.28 is equal to 360 degrees. What I am equating, though, is in radian mode, 2 pi rad is the same as 360 in this one. And so the reason we do that is because if I take this conversion factor, if you would, if I divide both sides by 360, right, what we end up getting over here is 1 degree, and then doing a little bit of canceling out, we end up with pi over 180. And so there is one of our conversion factors, right, because this is basically telling us that each degree is pi over 80 radians. So this gives us basically a way to go from degrees to radians. I just basically take the degrees I have, so let's experiment with this. Let's say I have 180 degrees, right? So what I have to do is take each one of these degrees and multiply it by pi over 180. Of course, the 180s cancel out, right? And what we're left with is pi, which should be no surprise because in our little experiment, we found that a half rotation, right, 180 degrees in degree mode was equivalent to pi in radian mode. So that's basically our conversion factor when we're trying to go from degrees to pi over to radians. Take each degree and multiply it by pi over 180. So I had 180 degrees, so we made that. Again, looking at it this way, right, if I now divide both sides by 2 pi, okay, what we end up with is we end up with 1 radian, and doing a cancelization, we get 180 over pi. So 1 radian is basically 180 over pi. And if you break out a calculator, we can actually estimate, right, what 1 radian is. And let me get that picture out that we did earlier. Let me find it. It should be down here somewhere. Where'd I put it? Because this is going to hopefully just put everything together for us. There it is. Just want to make sure I bring that sheet out a little bit. All right, so if you put your calculator out, you're going to find that this is 57 point yada 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 degrees. So it's just short of 60 degrees. All right, so 1 radian is about 57 point, like, I don't know, 2, whatever. I can't remember exactly. You guys are the one with your calculator in your hands. So take 180, divide it by pi, and I know for sure you're about 57, yada, yada, yada. It's really, really close to 60. And if we go look at our pictures, that's pretty much what we saw, right? That 1 radian length, right, is, you know, if we put my 90-degree angle right there, right, that 1 radius length sweeps out an angle that's roughly about 57 degrees, or really, really close to 60. So again, that takes us back to that idea, you know, there's a huge difference between saying 1 and leaving 1 by itself, because now, you know, at 1 radian is roughly about 60 degrees, 57 degrees, right, and 1 degree, right, means we're 1/36th of a rotation. So again, be very careful with your terminology with regard to that. So we now know what roughly 1 radian is in degree mode. And of course, this gives us a way to convert something that's in radians into degrees. All right, so and we'll practice that in a moment as we go along. But right now, since we're so used to degrees, let's get in the practice of converting degrees to radians. And I'm about 4 minutes into this, and I've got a lot of things to do. So how about this? Why don't, before I cut away the new video and do a bunch of math, I think we have enough time in this video to list our special angles in 1 complete rotation. So we're talking from 0 to 360 degrees. So what are all our special angles? Well, we had 0 degrees, right? We had 30 degrees, 45 degrees, 60 degrees, and 90 degrees, right? So all of these are basically your quad number 1, right? And then in quad 2, using our reference angles and whatnot, right, I think we ended up having, excuse me, we had 120 degrees, I believe 135 degrees, 150 degrees, and then we're at 180 degrees. So those are your quad 2 special angles, along with their quadrants. If we went to quad 3, right, our list now includes 210 degrees, 225 degrees, right, 45 degree reference, and then a 60 degree reference would be 240 degrees, and then of course we have the 270. And then heading into quad number 4, right, we have basically 300 degrees, I believe 34, I think that's going to be 340, let me make sure I do my math right here, 45, no, 315, right, and then we have 330, and then we're at 360. Sorry, I'm running off the board there. So those are all our special angles that we know we can actually find exact values for. All right, and that's going to be important because as we saw up here, we can take all these special angles in degree mode, right, things that are quadrantal or with 30, 45, 60 special reference angles, we can convert these all to their corresponding radian mode, and then we're going to have to get used to what they look like in that mode. So that's where I'm going to stop this one. Now that we have them, on our next video we're going to spend some time converting each one of these, seeing if we can see some patterns and whatnot, and just practice our conversion factors. Alright, so I'll cut away in a new video to do that.